Okay, we're going to be looking at problem number 22 on page 536 from chapter 10. I have the same table set up for helping us find type 1 and type 2 errors in context. It's possible once you get better at these problems you can do these without making the table, but a table is a good thing to fall back to. So I'm going to show it one more time as we work through this problem. The first thing it wants to know is which pair of hypotheses are correct. So in this case, it's talking about an automobile, a manufacturer, that it has defective parts on robots. And it's wanting to find out which set of hypotheses to test. Now, your book does it as it's a proportion. Your book likes to do pi as your population proportion, but I'm just going to use p, like several of you have said you prefer. So p equals 0.02. for my null hypothesis, and then the question is which alternate hypothesis is correct. And converting to robotic manufacturing, because of the expense, they only want to do it if they can make less errors than humans. So the error rate for humans is 2%, so they will only want to adopt robots if the error rate is less than 2%. And that means graphically what you would be looking at is you would have your sampling distribution of p hat, that you would be assuming would be centered at your 0.02, and you would only be looking for values somewhere over here that were extremely in that direction. Now, once we have these hypotheses, we can start talking about what they mean in the context of the problem. So if h sub 0 is true, basically what that is going to mean is that the robot's error rate is the same as humans. So pretty much the error rate for robots and humans workers is the same. If h sub 0 is false, that means you would adopt your alternate hypothesis, which would suggest that the robot's error rate is less than that of the humans. Now, you could, instead of comparing robots to humans, compare it to 0.02, but to get the full context of the problem, it's important to realize what they are actually trying to test. The significance is not whether it's less than 2%, but whether it's less than the human error rate, which just so happens to be 2%. Now, that means if you reject your null hypothesis, you're going to believe that the robots are less than the humans. And if you're going to fail to reject, I guess the most accurate way to describe that is to say that robots or that there is no evidence that robots are not equal to humans in their error rate. So now as we look at it, type 1 and type 2 error. Type 1 error here in the context of the problem would mean that robots and humans really perform at the same level. So they have equal performance. But they have equal performance in reality, but your test suggest that robots are better. Now, the consequence of making a type 1 error in the context of this, that's what a type 1 error means. The negative consequence of the type 1 error is the company would spend money investing in these robots, and they wouldn't actually see any increase in efficiency, so they would have wasted a lot of money. A type 2 error in context would mean that robots are actually worse than humans, are actually better than humans, because they would have a smaller error rate, but the test shows no difference. The disadvantage to a type 2 error in this case is that the company would not invest in the robots, even though they could have helped improve performance. This could cause them to lag behind their competitors in efficiency, and it could lead to some long-term issues because the company was not innovating the way they should. So a type 1 error is very serious in the short term because you wasted a lot of money on something that did no good. A type 2 error, though, is also good to avoid because if you make it, you would not innovate appropriately. Now, in the company's perspective, I would imagine they would be the most concerned, though, about the type 1 error. So they want to have the lowest probability of making a type 1 error as possible. So that's why they would probably set their alpha as 0.01, because setting a low alpha, low probability of a type 1 error, will by definition slightly increase your chance of making a type 2 error. But since a type 1 error is much more serious in the company's perspective, losing revenue is not good, but unnecessary expenses are terrible for a business. So you would try to reduce your type 1 errors by choosing the lowest value for your significance level or probability of a type 1 error as possible. So in summary, you have the ability to set your value for alpha, to basically decide how likely you are to make a type 1 error, but you have to remember that when you set alpha, if alpha increases, that means that beta will decrease, and if alpha decreases, that means that beta will increase. So if you're trying to avoid type 2 errors, setting your alpha level a little higher would be helpful. If you're trying to avoid type 1 errors, setting your alpha as low as possible. Usually businesses try to find some kind of a balancing point between the two, just keeping in mind which of the two errors they think is more significant. Generally speaking, alpha values can be anywhere from maybe 0.1 on, you'll occasionally see one higher than 0.1, but generally alpha values are 0.1 and then on down to 1%, or in some cases even less if it's very important you don't make a type 1 error.